Right, next up in our chemistry unit is a topic entitled smells. Slightly more pleasant than it sounds like it's going to be, so don't panic. Okay, so first question. What do all these 4 perfumes have in common? So we've got lavender, rose, sandalwood and chamomile. I'll give you a clue. So these are all perfumes that come from natural sources. Now, on the other hand, we have perfumes that look like these. So Chanel No. 5, Versace, random pictures I found on the internet of posh perfume bottles. But all of these are synthetic. So the key thing we have to remember is that perfumes can either be synthetic or natural. Those are our 2 options. We need to be able to recall both of them. So if they're synthetic, that means we've made them in the lab. So how do we make them? Well, the chemical that we are making is one called an ester, and it's the one that smells nice, really. Basically, almost any citrus smell that you get in perfumes and things, those are esters. Pear is the quintessential idea of what an ester smells like, but you can make them smell like whatever you want, really. So esters do occur naturally, but we can make them. So we can make them by reacting an alcohol with an organic acid. So when I say an alcohol is a group of chemicals, not just ethanol, which is the one that we all drink. Well, those of us over 18 drink when we go down the pub. But there are other chemicals that have got similar properties, and they are all called alcohols. So when I talk about an alcohol, I'm talking about a general chemical here. Same with organic acid. Organic acid is just a name for a group of chemicals. So, going back to my ester, to make my ester, I need to react an alcohol with an organic acid. And then I use a catalyst. So remember, we've mentioned catalysts before. Catalysts are things that make reactions go faster but don't get used up in the reaction. And the catalyst I would use here is sulfuric acid. So there's the general word equation. Alcohol plus organic acid goes to an ester plus water. So we get some water made out on the other side as well. And there's a specific example. So methanol is a type of alcohol plus butanoic acid goes to methyl butanoate plus water. The general one is enough, but if you can recognise these names, that will make life a little bit easier because they all have similar looking names when they're written down. So, things that we need in a successful perfume. So I've given you there 5 properties. Just pause the video for a minute and have a think about why it would be important to have those properties in a perfume. Okay, hopefully you've had a little think about it, and let's have a look at the answers. So, it needs to be non-toxic because obviously we don't want to poison the person who's wearing it. No one will buy it then. We don't want it to irritate the skin, because we don't want people to get rashes from wearing our perfumes, because again, no one will buy it. It needs to evaporate easily, so be very volatile. If it doesn't evaporate, we won't be able to smell it, and then there will be no point in wearing it, and no one will buy it. It needs to be insoluble in water, so we don't want it to dissolve in water, and that's because we don't want it to just wash off our hands really easily. We want it to sit on the skin for a long time. And the final one is we don't want it to react with water, because otherwise it could be that you're wearing a perfume, you sweat a little bit, and then you suddenly have some crazy chemical reaction happening on your skin, which could be dangerous. So we don't want that to happen either. So when I've been talking about volatility, we've mentioned it a few times because we talked about it when we were talking about different length hydrocarbons. Volatility is just the word that we use to talk about whether something can evaporate easily. Can it change from a liquid to a gas easily? And the reason this happens, if something is very volatile, it has weak forces between the molecules. If it's not volatile, it's got very strong forces between the molecules. So I have to put in energy to separate them out so that they can go floating around freely as gas molecules rather than liquid ones. So we've been talking about solubility quite a lot in this one, and it is a topic that we need to get our head around, and it's got quite a few words in it. So first one is solvents. So a solvent is a liquid that dissolves substances. The substance that we dissolve is called the solute. So, for instance, if you put sugar into your tea, the tea is the solvent and the sugar is the solute, because your sugar dissolves into your tea. The mixture formed by a solvent and a solute is called a solution. So if we go back to our cup of tea, your tea with sugar dissolved in it, so your sugary tea, is your solution, because it's a mixture of your solvent and your solute. Okay, so the components of a solution are mixed together and they don't separate out if you just leave them to stand. So if I just leave my cup of sugary tea, the sugar doesn't settle out, assuming I haven't put too much in. It just sits inside the tea and it doesn't come out. So substances that can dissolve in a particular solvent are soluble in that solvent. So my sugar is soluble in my tea. If I can't dissolve a particular substance into a solvent, then I would say it was insoluble. So, for instance, plastic is insoluble in tea. So if I stick plastic in my tea, it won't dissolve. Now, substances can be soluble in some solvents, but not soluble in others. So you have to pick the right solvent for the job that you want to do. So, for instance, if you want to try and get rid of, if you've got paint on something, you might not be able to wash it off with water, but you could wash it off with white spirit. So the paint is soluble in white spirit, which is why we can take it off, but it's not soluble in the water that you're trying to clean it with, just to give you some examples. Okay, so as I said, water is not the only solvent. Esters are solvents too. Now, nail varnish is a random little topic they throw in that they like to ask questions about. So nail varnish, you put it on your fingers and you don't want it to come off in water. So it doesn't, come off every time you wash your hands. So it is insoluble in water, which means that you have to have a nail varnish remover, something it is soluble in. And most nail varnish removers contain something called ethyl ethanoate, and that happens to be an ester. Now you may have noticed, but nail varnish remover's got a particularly distinctive smell, and that is the ester that is in it. So, whether or not a substance will dissolve in a particular solvent depends on the relative strength of the attractive intermolecular forces. This is higher, by the way. This is the top end of higher, so don't panic if this is all going over your head a bit. Basically, whether or not something will dissolve depends on how strong the attraction is between the particles in the thing you want to dissolve, so between your solute particles, how strong the attraction are between the particles in your solvent, the thing you're trying to dissolve it in, and then how much your solute and your solvent like each other. So if it's going to dissolve, your solute and your solvent have to like each other more than they like hanging onto themselves. That's basically what it boils down to. And we talk about that as being the intermolecular forces. So, why won't nail varnish dissolve in water? Well, it's because the attraction between water and nail varnish particles is weaker than the attraction that joins water to water and that joins nail varnish to nail varnish. So the attractive force between water and nail varnish particles is just not strong enough to pull them apart. They don't like each other enough. They're quite happy just being nail varnish holding hands with nail varnish and water holding hands with water. So what I want you to do before next session is there is an activity in your booklet, I think it's activity D, and it's entitled Investigation into Nail Varnish or something like that. I'm sure you'll find it. It's mostly blank sections with some headings. What I want you to do before next session is come up with a plan, so a method for how you would investigate different types of chemicals to see which one is the best nail varnish remover. So you want to try and think about how you could do it fairly scientifically, so you could come up with some concrete numbers, some concrete data maybe. So what are you going to do? And the other thing I want you to think about before next session and write down is any safety precautions you might need to take. So you're going to come up with a plan and your safety precautions. And when I see you, we are going to do this practical. Okay? Right, that is it for today. The only thing that I haven't touched on is animal testing. Now, we've already discussed this one before, and basically you just need to have an opinion and be able to say why in the EU it is banned to test cosmetics on animals. And I'm pretty sure you can all figure that one out, so I'm going to ask you when I see you next time. Okay? And that's it for this topic.